Okay. So I found a way of actually doing this in the same software. Hopefully this will be better as far as syncing is concerned. Um, so um, purpose of a switch. Okay. And you figure that, well, Kyle, we already talked about this. So, I mean, we already know what it's for. And technically, you might know what it's for, but you don't really know the purpose of why the switch was created. Okay, so let's do this. Since I can't have my pen just yet, we're going to have to do it this way. Why are you not capitalizing? Better. Okay, this is a MAC address. Okay, now what you don't know is every network card has a unique identifier. Okay, the chances of you having a network card, which is not impossible, with the exact same MAC address is slim to none. However, it has happened to me where I actually had to switch out the network card. I could not believe it when it happened. This was way back in the day. Okay, all right. The first 6 numbers of this identifier. Okay, these here. As a matter of fact, let me zoom in here. Okay, this is a unique identifier to the company that is creating the actual network cards, the manufacturer. Okay, so if I wanted to look something up, all right, like I have a MAC address of a device, but I don't know what it is, hey, I can take those first 6 digits, okay, and I can literally type it in with a MAC lookup, and it might say, hey, this is Kyle Incorporated. Okay? That's who created the actual network card. All right? Now, yeah, I'm just going to let the phone ring. You know it's funny, the phone never rings either. It's because I'm creating a video, of course, that's how it rings. It's done. Now, the last 6 numbers, okay? These are unique identifiers of the card itself, okay? So Cisco might be, we'll say oops, I know what I'm doing wrong. C1FA22, okay? Every time you see a network card with those first 6 digits, you know it's a Cisco product. All right, and of course, you're not going to commit this crap to memory. You're going to look it up every time you need to find out which one it is. All right? Some companies might have multiple manufacturer numbers, okay? Regardless, all right, Cisco is not the maker of the network cards. Does that make sense? But you never know. They might be. They may actually manufacture the cards or get somebody else to manufacture them and put their name on it. All right, it's easy. It's easily done. Easierly done than you think it is. Yeah, I have probably words today. Okay, so now we're going to leave that network adapter here, as far as the MAC address is concerned. Okay, we're going to do another one, and we're going to do it this way. Okay, and we're going to take that boy, slap it down here, and slap you down here. Now remember, with the hub, okay, with the hub, everybody gets the data. Sorry, everybody gets the data, okay? But a switch, this is the interesting thing, and a hub does nothing, okay? It's either passive or active. Active just means it has a power source, a power that you plug into the wall. And what it would do is every time data comes in, let's say it comes in on this port here, it's going to regenerate that data and send it back out all the other ports because it has power, has electricity. Passive hub means there is no electricity and it just goes and hits the actual hub and it shares it with everybody else. Okay? But a switch, and I want you to think about that. Okay, let's think about that for a second. If this was a hub, all right, this data here is going to be sent in, all right, and never forget this, and I'm going to repeat it probably 1,000 times. In order for communication between two devices, you must have 4 things. Okay? I'm going to type them up here. A source MAC, a destination MAC, God, turn the caps out, Kyle. Source IP and destination IP. Okay, meaning, now, if we were just using IPX protocol, which we're not using IP addresses at that moment for that protocol, all we would need is a source MAC address and destination MAC address. Okay, now, when we get to the OSI model, you're going to learn what these layers are. Source and destination MAC are layer 2. Source IP address and destination IP address are layer 3. Like I said, when we get to the OSI model, okay, which is the next lesson actually, this won't be in this video, we're going to learn why it's layer 2 and layer 3. A hub does not care. All it does is just share with everybody else, but a switch is a little bit more intelligent. Okay? Now, port 1, port 2. Okay? This is port 1. Come on, there we go. And this is port 2. I'll just put it right there. Matter of fact, let's do it this way. Let's make it a orange color. Okay? That way you can see it. Actually, I don't even like that. Let's do it this way. Leave it right there. All right? So this is what happens when I can't draw. But still, hey, like I said, we'll figure it out. What's going to happen is the second, every time data comes in on this switch port, let's say port 1, it's going to say, let me look at my table. Do I have something recorded for port 1? No. Well, let me add this number into my table. Now, let's say it did have something in the actual table, but it was not this MAC address. What's that switch going to do? It's going to erase whatever's in the table for port 1 and put in the new MAC address that it sees data coming sourced from. Okay? Now, I want you to picture this information here is what's in the data. Okay? You got the data, right? We're going to do it this way here. Okay. All right. Now, think about this. Boom. Okay? This is what we call a packet or a frame. I don't care what you call it. All right? Inside this envelope, okay, is my message. Blah, blah, blah. Yeah, who cares? There's glasses in there, but you get the idea. All right? This is the data. The data is wrapped around, okay, with layer 2 information, which would be the MAC address, source, and destination. It will build that information before it even sends it out. You must have that before a packet can be sent. Okay, wrapped around that will be an IP address. Okay, now as the data is sent out and PC2 gets that data, which we got to mark those too. All right, PC2 is going to look at the data and say, hey, the destination MAC address, is it mine? Yeah, it is. So I'm going to go ahead and open up the packet. If it's not mine, I'm going to destroy the packet. I don't want it. Make sense? All right, we're going a little slow here, but we're going to pick up, so don't worry about it. All right, now, can I move this up? No, I don't think so. There we go. Okay, now, the switch is intelligent because it will actually, I spelled this wrong here. Give me a second. All right, so think about how we do this and think about nesting dolls, Russian nesting dolls. All right, the smallest piece of the actual doll inside the other doll, inside the other doll, inside the other doll, right? That is your data. Okay, once I stick that data inside another doll and wrap it up with layer 2 information, what I have done is I have encapsulated that data, because when I first see the data, that's the first thing I'm going to see is that layer 2 information. However, I've also encapsulated that with the layer 3 information. So now the first thing I'm going to see is that layer 3 information. Okay, we have 7 layers, guys, that we would do this with in order for that packet to be sent. However, we're already focused on the 3 right now. Okay, the data, the layer 2, and layer 3 information, right? And mainly we're dealing with the layer 2 and layer 3. That's what we're focused on. We don't care what the data is. So the switch gets data on port 1, and the first thing it does is it looks at the source MAC address. Is that in my table? Yes, it is, or no, it's not. If it is, leave it alone. If it's not, replace the table with the new information. Now, that data has been sent all the way up through the switch, records what's on port 1, and comes back down to port 2, okay? But before it does that, it doesn't have the MAC address for port 2 yet. So guess what it does? It's an unknown MAC address. It doesn't know what port to send it to, so it sends it to all of them. All right, now PC3, 4, 5, and 6, that's not their MAC address. So they're still going to get the data, but they're going to be like, that's not for me, sorry, and block it. It's going to kill it. All right. However, PC2 here, it is PC2's MAC address, and it's going to open it up. Okay? And it's going to say, oh, okay, well, this is being sourced from AAAA. Let me go back and reply to AAAA that I got its message, okay, because, well, it's two-way communication. First of all, I actually asked for a reply in the message, right, saying blah, 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 hey, respond, let me know that you got this, all right, in theory, right? So now PC2 says, okay, well, let me go ahead, all right, I'm going to send data back to AAAA, except, all right, now the data that I send back to him, okay, which isn't going to be blah, 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 it's going to be blah, 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 accepted or confirmed, all right, and now I'm going to put my MAC address, BBBB, as the source, because it is. It's being sourced by me, my MAC address. So now that goes into the source part, and AAAA goes into the destination part. And that data goes back up to the switch, and first thing the switch does is says, oh, I got data coming on port 2 sourced from BBBB. Now, Do I have that in my table? No. Okay. So guess what? Oh, I did this wrong. Guess what? Now the table gets bigger. Yeah, I know this is tedious, but hey, we gotta get the point across eventually. I mean, somehow. Okay? And this table is built. Okay? Now, we call this a MAC address table or a CAM table. Okay? All right? We're just going to call it a MAC address table from our perspective. All right? And this is what a switch does. Do you not understand what this really means? Give me a second here. All right? What this means is, yeah, I know that's gross, but you got to deal with it. What this means is now no longer am I going to waste bandwidth sending out data to PCs that should not receive that data. Okay? PC 3, 4, 5, or 6 might have got the first packet or frame. Okay? If we are, okay, so we call layer 3 information, if the layer 2 information is encapsulated with layer 3 IP addresses, we call those packets. Okay? All right? The switch uses frames, which is actually the encapsulation of the layer 2 information. All right? When we actually do Wireshark stuff, you'll see what I'm talking about, because the source MAC address, destination MAC address, source IP, and destination IP is also encapsulated with the frame, okay, which is what we call the frame, which is the top layer. But again, nonetheless. Now, they might have got the first message because the switch had no idea what to do with that destination MAC address because it didn't have it in its table. It didn't know where to send it. So it sent it out all ports. Unknown MAC addresses goes out all ports. However, except the port it came in on. So that means when A sent that information, it saw that it was sourced from AAAA, it put it in the table, and then it sends out every port except port 1. Because why send it back out port 1 when it already knows that AAAA, there's no way BBBB is going to be on that port. So why send it back out that port? Right? This is the intelligence that we're talking about, why we would like to switch. Now, from here on out, as long as these two MAC addresses are on the table, from here on out, every time A sends, or PC1 sends data to PC2, it's only going to go out port 2. And every time BBBB or PC2 communicates with PC1, it's only going to go out port 1. Nobody knows that these two are communicating now. Don't have a clue. Okay? And that, my friend, is the purpose of a switch. All right? It is to, I guess, the best way, from my perspective, is to say this. First of all, it's a little bit more secure because we're only sending data to the people that we need to send it to, and nobody can sniff our packets because the switch is not going to send that data out of those ports. Okay? Now, that's one. And two, bandwidth. I don't have to eat up all my bandwidth. Imagine 2 and 1 sending file data, 10 gigs of data, copying from one to the other, and that 10 gigs of data went through PC 3, 4, 5, and 6. Every packet, every frame went to them. They'll drop it, but still their wire is being consumed from the bandwidth perspective. It's still getting eaten up. It's a lot of drop packets that they got to do, but they got to do it because if it was on a hub, it's going to eat up their bandwidth. All right, so when they communicate, now the communication is going to be extremely slow because 2 other PCs on the network are doing a file transfer of 10 gigabytes. Does that make sense? And that's not going to happen on a switch. It's only between those 2. Okay? So that, my friend, is the purpose of the switch. Okay? Now, routing and switching together. We've already looked at this from a telephone perspective. Okay? Let's look at it from a real network perspective, right? Which is why you're here, right? PC1 sitting here. Come on. Oh, I'm hitting control, not shift. I need to change this. I need to change this to default. Let's put that 24. Now, PC1. And this is going to be PC2 over here. Okay? Now, let's look at this, because now we're going to be using layer 2 and layer 3. Okay? Now, this it went back to the default. You son of a... All right, so no. Don't cuss it out. It went down to 18. That's weird, isn't it? Or am I crazy? Okay, now, think about what's going to happen. All right, we go back up to this slide here. We're going to grab all this. All right, now, I can't believe it. That's funny. All right, so let's go back, 24. PC1. All right. It's going to send data to the IP address of 185.what. Who cares? Okay. So now it has a destination IP address of 185. Okay. It has a source IP address of 192 because that's the network it's on. So it's going to put his IP address in there, all right, and it's going to put the destination IP address in there as well. That is the layer 3 information it has built, okay? Now, the source MAC, AA, destination MAC, BB, okay? And it sends that once that data is built on that PC, it sends it out, okay? We'll get more detail about, with this later on, but not in this video. Now, that gets sent out to the router. Now, the router says, oh, you want to go to the destination 185. Well, in order to get to 185, I got to send out this interface right here, okay? That goes into the cloud. Why? What is the cloud? The cloud is the ISP's configurations. It could be 50 routers between location 1 and location 2. We don't know. So we use a cloud in our diagrams to emphasize we don't know what's there. We just know when we send data out location 1, it's able to get to location 2, and that's the ISP's job. That's their method of getting the data from location 1 to location 2. All right? Your only focus was behind your router, which is on your side. Okay? Now, and finally, a packet comes in on our router, location 2 router, and says, oh, wait a minute, that's for network 185. I have an interface for that network. I'm going to go ahead and send it out through here. Okay? Now, it hits the switch. Okay? Of course, it's going to check the source MAC address, all that stuff. All right? And again, it's going to hit this PC. Now, when the PC gets this information, okay, it's an envelope. It's encapsulated. the first thing it's going to look at is the IP address. It says this is for 185.1.1.1. Well, that's me. So this belongs to me. If it was 185, 1.1. Anything else like 2 or 3 or 15 or 30, PC2 is like, that's not my IP address, and it'll drop the packet. Okay? Now, since it is my IP address, I'm going to go ahead and I'm going to open that up and see what's in there. And what am I going to see? The layer 2 information. Okay? And I kid you not, if that layer 2 is not the right MAC address for that PC, it gets dropped. But guess what? It is the right one. And I open it up again. Okay? And what's inside there? The data. Now, I got my data. Let me go ahead and send a reply since it's asking for a confirmation. PC1 is. Let me go ahead and send the data back. So I'm going to build, okay, the source IP address as 185, the destination as 192, and then my source MAC address of myself and the destination MAC address of where it's going to, okay? All right, and this is how the communication, this is why, guys, you need all 4. If you ever go through, okay, and look at the router and you get a log message that says encapsulation failed, okay, that means it could not build either the layer 3 or the layer 2 information. Something's missing, okay? Now, how does PC1 and PC2 build that layer 2 information? It knows what its own MAC address is. How does it know what the destination MAC address is, where they're going to? Well, let's go back to this page right here. PC1 is going to say, you know what? It wants to go to BBBB. Let me go ahead and look at my table, because every PC is going to keep a table of an IP address and the MAC address of every device it communicates with. We call this an ARP table, Address Resolution Protocol, ARP. Okay? And your ARP table is going to hold all the information for all the IP addresses that you've communicated with, and it will match the IP addresses with the MAC address of that IP. That's what's in the ARP table. Let's take a look at it. Okay. Here's the ARP table of my PC. Look at that. Okay. All right. IP addresses, MAC addresses. Some are dynamic, some are static. Okay. All right. Now you know what IP address I'm on my network. That's on my network. Okay. You also know the MAC addresses that I'm using. Okay. Knowing this information gives you the ability to send data to me directly if you want to do anything harmful or just be sneaky or whatever. Okay. But that's irrelevant. Every PC has a MAC address. Okay. Table. And we call it an ARP table. All right. If this information is not here in a table like this, and it does not have both the IP address and the destination. Now remember, these are not IP addresses of myself. Here is my IP address. Okay? All right? Where's my MAC address? All right? 192.168. Okay, that's 17.1, right? Okay. Here is my MAC address. That's how it builds its source MAC address information, because it already has it in a table. All right, and not to mention that you also keep in mind this MAC address that I got highlighted is burnt into the actual network card. There's no configuration needed. It's there. Okay, it is there. The operating system knows how to retrieve that information. It communicates with the network card. Keep in mind, guys, your operating system, what's its job? To tell the hardware what to do. It needs to openly be able to communicate, whether you want to look at a high level or low level, I care less. Okay, from a level, the fact that it can communicate with the hardware, and the hardware can communicate back with the operating system, giving it information that the operating system needs. All right, the operating system has a network card. That network card, okay, has what is called TCP/IP suite on it. Okay, it's a collection of protocols, TCP/IP. All right, okay. Was it transmitting? I'm not even gonna try it. IP is Internet Protocol. You know what? It is extremely embarrassing, but I could care less. Telecommunication, transmission control protocol. Duh. All right, transmission control protocol, TCP. I should have known. You know that you know. It's not the fact that I didn't know it, but again, guys, you get to the point where the damn protocols are so much in your head you forget. You know, it's been a long time since I've done this. Transmission control protocol is the reason why. It's TCP traffic. It's guaranteed traffic. Okay, and that's why we have to have a response. Okay, once a packet is sent, we got to get a response back. That's that guarantee effort. That's what the TCP is for. All right, well, that's what it means. But anyway, nonetheless, I couldn't remember to save my life. So anyway, now it's a good thing. You know, I didn't have one of my family members hanging up over a bowl of acid. So nonetheless, okay, so that's how we get the information from us, right? But to get it from the PC, PC1 is going to say, hey, I'm going to send out what is called an ARP request. Okay? Okay, because what I need to know is I'm trying to get to 192.168.whatever, which is, matter of fact, let's do it this way. Okay, I'm going to send out an ARP request because I need to know the MAC address for 192.168.1.2. Now this is interesting. If I need in order for me to create an a packet, do I need the source MAC and destination MAC? Okay, so in order to do this, that is going to be our source. This is going to be my destination MAC. Check this out. Every number in a MAC address starts off with 1 and ends with F. How does that work? This is how it works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay? A, B, C, D, F. E, F. Okay? Meaning that this one is 11, 12, 13, 14, 15. Okay? All right? We use A as number 11, B is number 12. Okay? That's how we do it. Because we only got one digit in each one of these. We can't put an 11 here because we only got one spot, one character. So we use letters to symbolize all the way up to 15. Now, when we set every digit in our MAC address to FF, what does that smart switch do? Because remember, it has intelligence. It's not a hub. That is a notification to the switch to send it out all ports. Now, why would it do that? Think about it. Well, it's asking for information, okay? And it has no idea who is going to respond. It doesn't have the MAC address for that PC. So everybody, PC 3, 4, 5, and 6 as well, is going to get this ARP request message. It's going to look it up, okay? And what it's going to say, because remember, our source IP okay? We're just going to put AAAA. Okay? And our destination IP is going to be what? Well, it knows the IP address. It just doesn't have the MAC address. So if it doesn't have the MAC address, it has the actual IP address of the destination, because I'm telling the PC, hey, I'm trying to communicate with 192.168.1.2. So the layer 3 information is built. It's just the layer 2 is not. And it cannot send it without the MAC address. So it needs to have it in this table. And it says, hey, FFFF sends out all ports. PC2 eventually gets that. PC 3, 4, 5, and 6 will get it too, but they're going to drop it because its IP address is not 1.2. All right? PC2 gets it. It says, oh, that destination is for me. Oh, this is a request from my MAC address. And guess what? It looks at its IP config information and says, oh, there's my MAC address. Let me go ahead and send that back. And now its source MAC address is going to be BB. Its destination MAC address is going to be AA, because it got that information from the source MAC address of the fucking frame. Pretty cool, huh? So now, as it goes back, all right, the source IP address is going to be 1.2, and the destination is going to be 1.1. And now, when PC1 gets that information, it can now build its table. And whatever it was trying to transmit in the first place, it can now do so and build that information with the layer 2 destination MAC address to complete the necessary information to send a packet, which you must have: source MAC, destination MAC, source IP, destination IP. Not bad, huh? Okay? A little bit more than just the purpose of the switches is connect these things together and be that. Okay? You guys can go as deep as you want with this information, as deep as you want. However, that is how this communication from PC1 to PC2 with the switches and the routers in between actually communicate. All right? And that's it for this video. And remember to always be strong, be determined, be Cisco.